Watermelons are an ancient crop, but the wild desert melons of antiquity hardly resemble the sweet treat that graces our summertime picnic tables. None can rival the Charleston Gray, a Southern American standard with genetic roots in Southern Africa. 5,000 years ago, the wild melons with their hard green flesh and thick rinds were essentially natural water bottles for those who roamed the Kalahari Desert, but the fruit tasted bitter. By 2000 BC, nomads had spread the wild watermelon north to the Nubian desert bordering ancient Egypt. Skilled farmers along the Nile River in today's Sudan domesticated the watermelon. Citron, or Citrullus amaris, was prized for its water content. Because it kept well, people also cooked it and ate the seeds, and at first its flavor hewed close to the wild variety. Then came a breakthrough. Farmers in that same part of Sudan found a non-bitter strain of melon and crossed it into the genome of Citrullus amaris to create our modern watermelon species, Citrullus lanatus. Through patient selection, sweeter and sweeter strains were developed, and by the time it reached the tables of Pharaoh, it had been transformed into a large, oblong fruit with sweet red flesh and was still 92% water. In the late 19th century, British botanist Joseph Hooker was the first to find remnants of seeds and leaves in Egyptian tombs. Other discoveries followed. Recent DNA analysis of those finds have proven them to be from sweet, red-fleshed watermelons. And images on ancient papyrus from the time of the pharaohs show just how similar those watermelons are to the ones we love today. During their time of exodus from Egypt, the Israelites longed for watermelons, which they called avatia, after an ancient Egyptian word which later gave the Arabic word batik, a generic term for all kinds of melons. The Moors introduced watermelon to Spain in the 8th century AD. There it became known as batik sandia, which became sandia, the Spanish word for watermelon. Egypt is still a major producer and consumer of watermelons, growing about 2 million tons per year, about the same as the U.S. China is by far the largest producer of melons, about 79 million tons annually, distantly followed by Turkey and Iran. A handful of farmers in the Egyptian desert still follow the growing technique recommended by the 12th century agronomist Ibn al-Awam. A series of small raised beds dug a foot or so into the sandy soil and surrounded by furrows into which water is pumped at just 3 critical times during the growing cycle. Only watermelon varieties that still carry this primitive resistance to desert conditions and drought can sustain this type of irrigation. Curiously enough, though, the old-style Egyptian farmers we visited a few years ago were growing the Charleston Gray, a famous variety born and bred in the American South, and they were the sweetest ever. Public plant breeder Charles Frederick Andrus created the Charleston Gray in 1954 at the USDA Southern Vegetables Research Station, now the U.S. Vegetable Laboratory in Charleston, South Carolina. Andrus wanted to introduce a watermelon that could resist Fusarium wilt, a devastating soil-borne disease. It also proved to be supremely adaptable, and as its admirers attest, one of the best-tasting watermelons ever. These remarkable qualities are thanks to the 5 different strains that were initially crossed with each other: the Africa No. 8, the Iowa Belle, the Garrison, the Leesburg, and Hawkesbury melons. 2 of them seem particularly important. In 1937, a Methodist missionary and farmer named Rush Wagner bred Africa No. 8 at the Old Umtali Mission, founded in the late 1890s under the leadership of Bishop Joseph Hartzell. The mission had a particular focus on agriculture, one that continues today at nearby Africa University. Wagner's round, drought-resistant fruit with its flaccid red flesh became popular among the colonists granted farmland by the Rhodesian authorities. Hawkesbury hails from Australia, where it was initially known as dark-seeded grey monarch and selected from a single mutation in a field of light-seeded melons called grey monarch. The plant's dark seeds were interesting, but not nearly so much as its complete resistance to Fusarium wilt in a field overrun with the disease. The seeds have been key in breeding modern watermelons with high resistance to the disease. One of them, Charleston Grey 133, also known as Purdue Hawkesbury, was bred at Purdue University in Indiana to resist Fusarium wilt, a fungal disease called anthracnose, and sunburn. A bitter strain of the Hawkesbury was even selected and grown for the compound cucurbitacin, which is extracted and used to fight rootworm in cornfields. With its sweetness and versatility, Charleston Grey illustrates how genetic diversity and creative public breeding programs help farmers and delight the rest of us.
Thanks so much for watching Seed Stories. We love bringing you the backstory on these amazing varieties. Be sure to click the subscribe button so you won't miss a single episode.